Okay, we're going to talk about how to translate words into equations. You know, the big thing with word problems is it's not like reading an English book. You got to read it slow. I highlight stuff. I do all kinds of stuff, you know, that I wouldn't do when I'm reading an English book. I mean, I read very, very carefully and slowly. First thing is figure out what is it asking you to find. That's important. Usually it's at the end of the problem. It'll ask you a question. So the variable is the thing that you're trying to find at your unknown. You can choose X, but you can use meaningful variables. Like if I'm solving interest, I might solve for I. Principal, I might use P. So, you know, you can use meaningful variables in that way, you know, remember what it is that you're solving for, what you're finding. It helps to write down what the variable represents. So like I know that X is the interest rate on this account. Reread the problem and write an equation. Sometimes, you know, you might have several equations. You know, I usually like to kind of work them a sentence at a time, and sometimes it'll generate a system. Solve the equation. All right, answer the question of the problem. So sometimes you solve an equation, but that's not the answer, but you have to do something else to get the answer. So you want to make sure you answer it as what they're asking for. And check your solution. If you've got time, I use units too to make sure that it just helps me realize I'm answering the right thing. It should make sense. You know, if I get an interest rate of -4%, I've done something wrong. It should make the equation true that you have. If it doesn't, you know, then the math was wrong somewhere. You know, time, if you ask for time and end up with a negative value, that's just not going to work, all right? Or distance is never negative. So those things can be, you know, indicator of errors with money problems. You know, if you have an interest rate of 4%, you invest $1,000 for 2 years, you shouldn't end up with $5 million at the end of 2 years. That's when it tells you you've done something wrong. All right, so you want to keep checking that. So let's work a problem. For formula I equals PRT, this is what they call the simple interest earned. What simple interest is, at the end of the account, they apply the interest. At the end of the time, they apply the interest and you owe the interest. Most banks, nothing really works that way, but this is what they start with, okay? Usually compound interest. You have to pay a certain percentage of your interest every year, every month, whatever they decide. So I equals PRT, simple interest, that's your I, from investing P dollars at an interest rate of R for a period of T years, okay? So with interest rates, just one thing to keep in mind, you're always going to be as decimals in a mathematical equation. In the calculator, when you get to the finance app, the interest rate is not entered as a decimal, like 5% is literally 5, but only in the finance app. Okay, anywhere else in the calculator, it's a decimal, okay? So when we're just doing problems, it's going to be a decimal, it has to be written as a decimal, okay? So we're going to write equations for the following problems. Mason invests $5,000 at 4% simple interest for 3 years. They really should ask you a question. So let's say I want to know how much money he's going to have at the end of the time, all right? But I'm using this equation, I equals PRT. And what we're going to do is we should have, you see there's a total of 4 variables here, I, P, R, and T. We should have 3 of them. All right, so I have to ask myself, 5,000, what's that? Well, that's my starting money, so that's what they call the principal. P equals 5,000. That's my starting value. All right, it's 4%. Well, that's obviously my R, my interest rate. So 4% as a decimal is 0.04. Don't forget to put the 0 in front of it. And 3 years would be time. So if I plug in P, R, and T, what I'm going to get is the interest. All right, so the principal is 5,000. The rate is 0.04. And the time is 3. So I'm just going to type that in my calculator. I do have one here. 5,000 times 0.04 times 3. And I get $600. All right, so I'm going to put some units on there. So this tells me in 300, this is not how much money he's going to have. It's the interest he earned. He earned $600 in interest. So he would have, if he leaves that money in there, he would have $5,600 because I add the principal to the interest to get his ending balance. Okay. All right, next one. Caleb earns $500 in interest from investing some money at 12% simple interest For 5 years. All right, so we're going to use the I equals PRT because it's simple interest. Again, this is not practical, but we're going to use it anyways. All right, so $500, you have to ask yourself which one of those variables in that is that. That's what he invests. So the principal is 500. 12% is the interest rate, obviously. So we're going to write that as a decimal. That's 0.12. Oh, no, sorry. I have to cancel that. I have to read the whole problem, and I almost got caught here. All right, $500 in interest. So $500 is my interest. So let's change that up there. I equals $500. All right, and 5 years, so T is 5, right? All right. So what am I missing? I'm missing the principal. So that's what I want to know. I want to know how much money he initially invested. That's the question they're going to ask. So let's plug in the stuff I have. I is 500. The principal we don't know. The rate is 0.12. And the time is 5. So solve for P. I'll take 0.12 times 5 first, I guess. And I get 0.6. So I get P times 0.6 equals 500. So to solve for P, since 0.6 is multiplying P, we're going to divide by 0.6 on both sides. So 500 divided by 0.6, I get $833. Really? Oh, because it's 12% interest. $833.33. Okay, and I can check that. So if I multiply that by 0.12 and 5, I should get 500. So if I do that times 0.12 times 5, I get $500. Okay. All right, so there we are. All right, so we're still working with simple interest. All right, right here. So same equation. I equals PRT. All right, 4 years, so that would be time. Rick's investment of $800, so that would be the money he put in. That's the P, that's the principal. Has earned $200 in simple interest, so that's the I, right? That's how much he earned. So here they would ask me, you know, what's the interest rate on his money? So I'm just going to plug stuff in and solve for that interest rate. So I is 200, P is 800, we don't know R, and T is 4. So to solve for R, well, I think I'll just multiply 800 times 4 is going to be 3,200. You can check it on a calculator. So if you divide by 3,200, so I'm going to plug that in a calculator. So 200 divided by 3,200, whoops. I get an interest rate of 0.0625. Remember that this is as a decimal. So to get the actual interest rate, I'm going to move the decimal place over 2 or simply multiply by 100. So you get 6.25% interest. Is that a reasonable interest rate? Yeah, I wish you'd get that today, but it's a normal number. It's not 65% or something like that. All right. Let's see. Karen invests $600, same problem. Simple interest, so I equals PRT. So 600 is obviously going to be my P. The interest rate is 3%, so as a decimal, that's 0.03. And $50 is the interest. So here I'm missing time, so they would say, you know, something like, how long does it take her to earn $50 in interest? All right, so we're going to plug stuff in. And we assume it's years unless they say otherwise. P is 600. R is 0.03. And we have T here. All right, so I'm going to do 600 times 0.03 first. So I get 18. 50 equals 18T. So if I divide by 18, T is going to be 50 over 18. I get 2.7, 2.8 years. Well, we'll just do it to tenths because there's not much, you know, we don't need to do much. So that's about 2.8 years that it's going to take her to save $50 in interest. Okay, so it's all about, you know, reading, plugging in variables, making a list is helpful. All right, making sure your answer is reasonable. Okay, so we're going to write an equation. So X is the number of nickels. I'm going to write, you know, I'm just make a list. Number of nickels. And Y equals number of dimes. That's a hashtag. It just doesn't look like it. All right, so Jane has 7 more nickels than dimes. 7 more nickels than dimes. So I don't really care about Jane too much, but we have 7 more nickels than dimes. So how do I write that? So this would be equal. So if the number of nickels equals the number of dimes, it would be this. Now this is a little tricky because it's 7 more nickels, so that would be the dimes, which are less, plus 7. All right. So, and if you're not sure, you know, pick some numbers and check it out. So, you know, if I think about it, you know, if I have if I have 1 dime, if I add 1 plus 7, I'll have 8 nickels, and that fits with the equation. So plugging in some numbers can help too. You know, where do I put that plus 7? All right. Ray has 3 less nickels than dimes. Nickels are X, dimes are Y. 3 less nickels than dimes. So his nickels are less. So the dimes, if I take the dimes and subtract 3 off, that would be the number of nickels. Okay, and again, you have 4 dimes, they have 1 nickel, and that's exactly what I want to do. Okay. All right, the word twice, you have to be careful. Kate is twice as many dimes as nickels. So dimes, no, X is nickels, Y is dimes. I want to have twice as many dimes. The dimes is bigger, so I'm going to multiply the nickels by 2. Okay, check it. So if nickels is 1, dimes would be 2 times 1, right? It would be 2. Okay. Steve has a total of 16 coins. Total tells me it's a sum, some nickels and some dimes. So a total is just X plus Y, right? So X plus Y has to equal 16. Kim has nickels and dimes that have a total value of 345. So the difference between 4 and 5, 4 is just counting up the coins, 5 is counting the values. So we have to multiply by the monetary value. So the value of a nickel, or the money, is 0.05. So the money that I get from nickels would be 0.05 times the number of nickels I have, right? And the money that I get from dimes would be 0.1, 10 cents, times the number of dimes I have. And I know that that equals $3.45. A lot of times you'll see these in conjunction with each other, like one for the number and one for the money. So just remember to multiply the value of the coins by their value, the number of coins by their value. Okay. All right, so let's see. Let X be the number of ounces of food A, Y be the number of ounces of food B, and Z be the number of ounces of food C. Write an equation for each problem. Okay. So I would love to have used A, B, and C, but they're using X, Y, and Z. All right. Sarah will eat a total of 24 ounces of food, some A, some B, and some C. Well, the total is the sum, so I know that means I have to add them together. Oh, it's not A, it's X plus Y plus Z, right? Sometimes if they do this, I'll usually put the X, the Y, and the Z up above it so I remember what's what. All right, Sam will eat twice as much of food A, which is X, as food B, which is Y, and food C combined. So let's read it again. Sam will eat twice as much of food A as food B and C combined. All right, so B and C combined would be B plus C. Y plus C. And the food A is X. So I want X to be twice as much. So that means I'm going to multiply the b and c by 2. That's the thing with twice is you have to be careful of, right? Because that way I'll get 2 times what y plus c. That's what I want. Okay. All right, food A, which is X, costs 50 cents an ounce. Food B costs 70, which is Y. And food C, which is Z, costs 60 cents an ounce. Kip will eat some of each type of food. He will spend $7.20 on the food. All right, so all I have to do is, again, the total food money, I'm going to do the value of the food. So the cost of A would be 0.5 times the number of ounces of A I eat, which I called X, plus this would be 0.7 times Y, and then food C is 0.6 times Z. Okay, there's our equation. All right, let's try another one. Let's see, this is Y and this is Z. I'll put them underneath. All right, Corey will eat 5 more ounces of food B than food C. Okay, where do I put the 5? Well, I want food B to be more, so I'm going to put 5 here. Let's see. Okay. Be careful with the word twice. Paul will eat twice as much as food A will eat twice as much food A as food B. So this is X. This is Y. He's going to eat twice as much as X, and he is Y, so the twice goes right here. Okay, because X has to be bigger than Y. Right? All right, let's do some investment problem. All right, let X equal the dollars invested at 7% interest. Y equals the dollars invested at 6% interest. And Z equals the stuff invested at 11%, dollars. Okay. Sam is investing a total of $7,500, some in each of the 3 accounts. So since these are just money, it has nothing to do with the total money is just X plus Y plus Z, right? Because that's the dollars invested. All right. So I know that 7,500 equals X plus Y plus Z. Okay. Now, Carl will invest money in all 3 accounts and will earn an annual interest. Now, this is different. Now we have the interest. So the interest income is 7,500. So the interest from X would be the money, which is X, times the interest rate, which is 0.07. That's going to be the interest. And then for Y, the interest is 6%, so it's 0.06 times the money. And for Z, it would be 11%, 0.11 times the money. Okay? So here we're talking about interest, so we have to multiply by the interest rates, whereas above we were just talking about the money, so it's just the total money. All right, Ray will invest 3 times as much money into 7%. So 7% is what? 7% is X, is 6% is Y. So this is X and this is Y, just so I remember the difference. Okay. So we have investing. It's just the money, has nothing to do with the interest rates. All right, I want X to be 3 times as much as Y, so that has to go there. Okay. All right, let X, Y, and Z represent the length and the size of a triangle. X is the shortest, Z is the longest, okay? So the shortest side, that would be X, is 5 inches shorter than the medium side, which is what we call Y, right? So the word is, that's a good ticker for equals. X is 5 inches shorter than Y. So Y, if I want to take 5 inches off of it, we're going to subtract 5. The longest side, that's Z, is equals twice as long. Be careful with that one. There's the shortest side, which is X. Okay. So Z, well, it's not too bad because twice as long as X would be 2X, right? Okay. The longest side, that's Z, is equals 12 inches longer than the shortest side, which is what we call X. Okay, so Z equals, if it's 12 inches longer, that means all I gotta do is add 12. Okay. The perimeter of the triangle is 84 inches, so that would be the sum of the 3 sides. Remember, the perimeter is the distance around it. x plus y plus z is 84. Okay. All right, so that's it. Today was just setting up word problems. Again, word problems, you know, you have to just take them slowly. If you help, things you can do like list the variables like I did here can help you catch errors, making sure your answers are reasonable, underlining, writing above and below what the variables are. These kind of things can really help you as you work through the word problems. All right, well, that's it for this part of 4.1. This was on page 37 in your booklet, and so that's it. All right.